Welcome to Technauts, a podcast by Inwedo, where we explore how innovation works in practice. Today we're talking about Model Context Protocol, an open integration standard that lets you connect AI to the systems already running in your organization, including legacy and distributed ones, without migrating entire systems or rewriting critical applications. With MCP, you can safely deploy AI models that don't just analyze data from ERP, CRM, or SharePoint. They can act on it. What's more, once implemented, MCP becomes a shared integration layer you can freely connect different systems and AI models to in future. In this episode, we'll break down what MCP means for business, how it works, and where to apply it, and why organizations that standardize how AI connects to their data today will gain a lasting advantage. Let's get into it. Companies today have more data than ever before. Yet despite this abundance, many strategic decisions are still made based on intuition, manually compiled reports, and teams' informal knowledge. While AI models effectively analyze data, generate summaries, support customer service, and automate documentation, scaling artificial intelligence in enterprises remains the exception, not the rule. MIT research shows that as many as 95% of enterprise AI projects stall before they deliver business value. Why does this happen? Not because the models are too weak. On the contrary, they're increasingly sophisticated and capable. What holds them back is the lack of systematic access to data, and therefore the lack of full context about how the business operates. According to Deloitte, 62% of business and technology leaders identify lack of data integration as the biggest barrier to AI adoption. The company data that could power these models is scattered across different databases, files, and applications, often locked in silos, difficult to connect, not ready for LLMs to interpret. This fragmentation is the result of years of decisions and changes within the company. Each system was built to solve a specific problem. ERP organizes finances, CRM manages customer relationships, production systems control inventory. Each has its own storage format, its own API, its own logic. That's why building dedicated integrations for each AI project consumes time and budget while creating growing technical debt. Organizations in this situation need an integration approach that allows AI models to operate within the tools the company already has, organizes access to data from different systems and departments, and eliminates the integration chaos currently blocking scale. This layer is created by Model Context Protocol, an integration approach that lets you connect the capabilities of AI models with the realities of business processes, without migration and without abandoning years of technology investment. So, what is Model Context Protocol? It is an open standard that gives AI access to company data and tools in a controlled, secure, and scalable way. Instead of building separate connections between AI and each data source, MCP creates a common access layer. The model doesn't need to know how each system works. It simply says what it needs in a standard form. MCP translates that intent into specific actions in source systems and returns results in a consistent format. What makes MCP actually worth the effort? There are three main benefits of the implementation. First, you build one integration layer. The first use case requires full configuration, but each subsequent one, using the same systems, runs on ready infrastructure, reducing the cost of future AI projects. Second, you maintain freedom to choose your AI model. MCP works with cloud-based models, Claude, GPT-4, Gemini, as well as those run locally, and you can swap models without rebuilding integrations. And third, you keep full control over your data. It doesn't leave source systems. Every AI operation goes through your security rules with logging and audit trails. As a result, MCP organizes the way AI communicates with the company's systems, regardless of their age, architecture, or technology. It becomes a shared integration layer for building successive AI applications. Now, there's something we need to address before going further. Every AI integration, regardless of the technology you choose, requires the same foundation: clean, consistent data. If your sources contain duplicates, errors, or conflicting definitions of the same concept, for example, a customer in the CRM refers to a company, while in the ERP it refers to a contact person, the AI will produce answers that are just as inconsistent as the data it works with. Consolidating sources, improving quality, and standardizing definitions is essential for AI implementation to deliver results. MCP is no exception here and won't do this work for you. But why should you invest in data quality now? Once your data is consistent and an MCP server is in place, every new AI tool can access it without the need for another integration effort. Setting up connections and permissions takes hours rather than weeks of development. As a result, the value of your investment in data quality increases with every additional AI initiative. What's more, you don't need to standardize everything at once. You can begin with a single system, for example, the CRM, improve the quality of its data, build an MCP server for it, and launch the first AI use case. Other systems can be added gradually, each when it makes sense for the specific project. How is this possible? The answer lies in the way MCP connects systems with AI. Let's look at a specific business scenario. A large logistics company wants to use artificial intelligence to monitor the risk of delivery delays to customers in real time. The data needed for this is distributed. Orders and routes are in the TMS system, shipment statuses are in the courier application, and customer reports are in the ticketing tool. The traditional approach requires building a separate integration and its own data processing logic for every system. Because each one exposes data differently, every connection needs dedicated code and ongoing maintenance. When a new AI project needs to use the same systems, the entire process must be repeated, building integrations, testing them, and deploying them again. This approach is time-consuming, error-prone, and limits the ability to scale AI across the organization. The scale problem becomes visible quickly. With 3 systems and 2 AI projects, you already have 6 separate integrations to maintain. And any change, an updated API in a source system, a new AI model, an additional data source, requires updates across all connections. It's a model that increases the cost and timeline of each new project instead of reducing them. With MCP, the project begins by identifying the minimum set of data needed for the AI use case. Some of the data alignment takes place in the source systems, for example, synchronizing customer identifiers between the TMS and the ticketing tool. However, most of the logic can be placed in the MCP layer, such as mapping different parcel statuses to a shared dictionary, or defining what counts as a delay. This helps the team avoid risky, time-consuming changes in critical applications. The next step is to define which data and operations from each system should be available to the AI. With these requirements in place, MCP servers are configured to provide the connection between the model and the source systems. From that point on, every AI request follows the same flow. The AI model sends its instruction to the MCP client, the layer responsible for communication. The MCP client translates the intent into the protocol format and forwards it. The MCP server receives the request, checks its context and permissions according to local security rules, and then executes the appropriate actions in the source systems. The result is returned to the model through the same path, in a consistent, standardized format, ready for further processing. With this setup, the model can not only answer a question about delays in real time, but also analyze delay risks autonomously, classify situations by escalation level, and generate alerts or recommendations. Once the MCP servers for these three systems are in place, the company can use them for the next project. For example, optimizing route planning based on historical delay data. This new project may require some additional data alignment, such as standardizing route codes, but the integration infrastructure is already there. The new AI agent uses the existing MCP servers, where the traditional approach would require building new integrations. The more business use cases rely on the same data sources, the lower the marginal cost of each additional use case. The organization builds a library of ready connections and gains an integration infrastructure that accelerates every subsequent AI experiment. Now, here's why this matters beyond just cost efficiency, and why you should pay attention to what's happening with MCP right now. Model Context Protocol emerged at the end of 2024 as an open source initiative by Anthropic, and it quickly became clear that it was not just another AI integration tool. MCP addresses a gap the industry had been unable to close for years: the lack of an open, shared language for communication between AI models and enterprise systems. In the following months, MCP began to be implemented where today's AI integration standards are being shaped. Microsoft integrated MCP with its semantic kernel platform, OpenAI announced compatibility within its developer tools, and Google is testing its implementation in the Gemini ecosystem. At the same time, the community created ready-to-use MCP servers for common enterprise tools, from PostgreSQL and Salesforce to Microsoft 365 and SAP. These make it possible to connect your systems to AI without having to build every integration from the ground up. The pace of adoption and the level of vendor support indicate that MCP is becoming an emerging standard for linking AI models with enterprise tools and systems. If you're considering AI adoption, this means building on infrastructure that avoids vendor lock-in. You won't need to rewrite integrations when you change models or platforms. But let's be honest, Model Context Protocol isn't the only way to connect AI to your systems. Companies use various methods like APIs, LLM plugins, RAG-based integrations, or proprietary middleware. Each of these approaches works as long as the number of connections and use cases remains limited. When organizations add more models, data sources, and processes, traditional integrations start to spiral out of control. Every new function requires its own connection, and every model update demands code changes, testing, and a review of permissions. Over time, this environment becomes increasingly expensive to maintain, harder to audit, and less stable at scale. Model Context Protocol was created in response to this complexity. It standardizes the way AI models connect to a company's data and tools, introducing a shared integration language. So the model receives information in a consistent format, regardless of which business system it comes from. So how does MCP actually compare to the alternatives? Let's look at the key differences in terms of scalability, security, and long-term maintenance costs. On scalability, traditional LLM plugins and APIs use point-to-point integrations. Each new connection requires separate code. Middleware and RAG connect multiple sources, but major data changes require retraining the model, difficult to maintain at scale. MCP provides a single integration layer for all models and data sources. Scalability is built into the protocol. On maintenance cost, traditional integrations grow exponentially with the number of connections. RAG is high maintenance when models or data formats change. MCP is stable, one layer serving all systems and models. On flexibility, traditional plugins tie you to a single model or API. Middleware limits you to the chosen framework. MCP is fully model agnostic, works with cloud, on-prem, and open source models. On security, traditional APIs depend on the provider's security, and data often leaves the organization. RAG requires an additional security layer for embeddings and caches. MCP keeps data in source systems. The protocol enforces permissions before data is shared. Centralized logging supports audit and compliance. On time to deployment, traditional approaches take weeks or months of development. RAG takes days, preparing embeddings, configuring sources, and security. MCP takes hours with ready to use servers, or days if custom servers are required. As you can see, traditional approaches work at small scale but break down as complexity grows. MCP is designed for that complexity from the start. Which brings us to what actually changes when you implement Model Context Protocol and how it expands the capabilities of AI in your organization. When AI connects to your data and systems through a single integration layer, it can support you in different ways, from answering questions to carrying out tasks to responding autonomously to events in business processes. In every case, it is you who decides which systems AI can access and how broad its scope of action should be. Some steps can be fully automated, especially when they are routine and carry low risk. Others remain decisions that require human approval. MCP does not impose these rules. It simply provides a shared, standardized way to express and enforce them. Depending on how much access and autonomy you give it, AI can play 4 different roles. The first is the conversational assistant. In this role, AI can search and combine data from different systems, from CRM and ERP to document repositories, presenting results in a clear form and in line with the user's permissions. This assistant answers questions and helps people find information across company systems, cutting search time and breaking down data silos. The second role is an automation assistant. Once AI can interact with systems, it can also carry out tasks, creating tickets, updating records, generating reports, or triggering processes in other tools. These solutions combine conversational capabilities with the ability to act. The assistant completes tasks automatically and informs the user about the steps taken. The next level is an AI agent capable of monitoring processes independently and reacting to events. It can detect anomalies in data, initiate corrective actions, or send alerts to the relevant teams, all within the scenarios and limits defined by the organization. According to McKinsey, combining generative AI with an agent-based operating model can automate 60 to 70% of tasks currently performed by people in sectors such as banking or insurance. This is no longer just optimization. It's a fundamental change in how businesses work. The most far-reaching scenario is enabling external AI assistants, such as ChatGPT, Claude, or Perplexity, to access selected company data. In this case, the organization controls which information is shared, while customers can ask the AI assistant about products, receive up-to-date answers, and complete a purchase without visiting the website. This scenario is particularly relevant for sectors with rapidly changing product catalogs, such as retail, e-commerce, or booking platforms. How do these roles translate into business applications? Let's look at 4 examples of how AI can be used, from responding to production incidents to building an advantage in a new sales channel. First up goes food production, where AI can work as a dispatcher and supervisor. In the food industry, any irregularity can lead to downtime or the loss of an entire batch of raw materials. Companies often have sensors and quality systems to detect such situations, but the data sits in separate environments, which slows down response times and makes quick diagnosis harder. When AI has access to all these sources through MCP, it can monitor the entire production process continuously. The agent analyzes data from production line sensors, temperature, pressure, speed, humidity, combines it with information from ERP and MES systems, and reacts as soon as it detects a deviation. An example: a sudden drop in pasteurization temperature triggers a sequence of actions. AI starts with steps the organization has allowed it to perform autonomously. For example, analyzing heater parameters, checking maintenance history, and reviewing the status of the current batch. If the diagnosis indicates a problem, the agent follows the scenarios defined by the organization. If the situation falls within routine actions, AI can respond autonomously. For example, create a service ticket and flag the batch for inspection. And if the scenario requires a human decision, the agent prepares full context on the event and hands responsibility over to the supervisor. For example, when the situation may require stopping the line or discarding raw materials. In both cases, AI informs the production manager about the cause of the event, the status of the batch, and the estimated downtime. As a result, the response time drops from hours to minutes, regardless of whether the action is taken by the agent or a human. All steps, both autonomous and those handed over for approval, are recorded in the system, making it easier to meet HACCP and BRC requirements. Now, let's move on to construction industry, where AI can help in maintaining the golden thread across the project lifecycle. One of the biggest challenges in construction projects is keeping data consistent from the concept phase through construction all the way into operation. BIM models, schedules, inspection reports, project correspondence, and handover documentation often exist in separate systems. As a result, information about changes, decisions, or discrepancies gets lost between tools and teams. MCP makes it possible to connect these sources so that the information becomes accessible in one place, with full context and without switching between systems. An AI assistant connected to BIM models and project management systems can analyze issues, changes, and schedules in real time. When a discrepancy appears, for example, between technical documentation and the data in the 3D model, AI can highlight the elements that require verification or automatically update a task status according to predefined rules. A project manager no longer needs to search through files and spreadsheets. They ask a question, and artificial intelligence pulls the relevant data from multiple sources into a report or visualization. This increases process transparency, reduces the risk of errors during handovers, and shortens the time needed to prepare progress reports. Over the longer term, AI also helps preserve project knowledge. With access to full historical context, it can reconstruct the rationale behind decisions made months earlier, making it easier to onboard new team members and to account for changes in scope. Here's another example: IoT security, where AI acts as an incident analyst and coordinator. In organizations managing distributed IoT infrastructure, the biggest challenge is not a lack of data, but an excess of it. Sensors, alarm systems, cameras, routers, and endpoint devices generate thousands of alerts every day, most of which turn out to be irrelevant. Security teams still need to review them, which slows down the detection of real threats. MCP makes it possible to deploy AI agents that monitor all sources in real time. The agent brings together signals from cameras, sensors, and network logs, analyses them in context, and classifies them by risk. For routine cases defined by the organization, such as sensor malfunctions or known harmless anomalies, the agent can handle the event autonomously with full logging. In higher risk situations, for example, a simultaneous door sensor failure and an attempted unauthorized login, it passes the security team a complete package of information: diagnosis, context, and a recommended response. As a result, analysts no longer drown in low priority signals and can focus on incidents that genuinely require a decision. Response times improve and operational resilience increases, without giving up control where the consequences matter. In every case, risk assessment, event history, and the actions taken are automatically recorded for audit and security policy compliance. And finally, retail, where AI becomes the next online sales channel. Across e-commerce, we're seeing a clear shift in buyer behavior, with more customers beginning their purchase journey by talking to an AI assistant. According to market analyses, traffic coming from generative AI sources increased by 1,200% between July 2024 and February 2025, and customers guided by AI abandoned their baskets 23% less frequently than other users. ChatGPT, Claude, and other AI assistants, however, still operate mainly as intelligent search engines. They browse websites and return lists of links because they do not have access to the data required to provide precise answers. The customer then has to check availability and compare options manually. And with each additional step, purchase intent declines. Model Context Protocol allows retailers to share product data, prices, stock levels, and pickup options with AI assistance in a controlled way. This lets AI respond with specifics, where the product is available, at what price, and which purchase methods are possible, instead of redirecting the customer to multiple pages. MCP also opens the path to transactional integration, where an AI agent not only finds the product, but guides the user through the entire purchasing process. Market direction already points this way. Google is implementing solutions where an agent can check product availability and initiate a transaction once the user approves it. And OpenAI has launched an assistant that helps users search for products, asks clarifying questions, analyzes data, and supports the purchase decision. For retailers, this is an opportunity to enter a new sales channel where purchase intent is exceptionally high. Companies that move first will gain visibility, while competitors are still figuring it out. So if you're looking at these use cases and thinking about implementation in your own organization, where do you actually start? Implementing MCP doesn't start with technology. It starts with understanding how your organization works with data, what connects your systems, and where AI can help. Only on this basis can you build the integration layer that allows models to operate predictably, securely, and in line with your business requirements. The four-step framework below, based on the Bridge AI methodology used at Inwedo, shows you how to plan MCP implementation, whether you deliver it internally or with a technology partner. If you want to learn more about the methodology itself, there's a link in the episode description. The first stage is environment audit and data source prioritization. It takes 2 weeks, focuses on diagnostics, workshops with IT, operations, security teams, and system users. The goal is to understand how the technology environment works and which data is relevant to the planned AI use cases. At Inwedo, we use the Polaris framework, our standard for IT project risk and quality assessment. At this stage, we identify systems and data sources critical for the planned AI use cases, existing integrations and their limitations, undocumented workarounds, quick wins, data that can be plugged in quickly and safely, and potential technical and organizational blockers. The outcome is a clear map of data and dependencies, together with priorities and the scope of work for the subsequent phases. The second stage is MCP integration. At this stage, the working MCP layer is created, the layer that connects AI with selected systems. We start with the source that offers the greatest business potential and the lowest technical risk. The work includes building an MCP server for the selected data source, configuring secure permissions, initially read-only, testing AI scenarios and validating the results, enabling the ability to perform actions in systems, and ensuring compliance with existing security policies. After 10 weeks, you have a working MCP proof of concept, a stable, secure integration layer ready to connect AI models. Your existing systems stay as they are. MCP connects to them through their current interfaces and respects their security rules. Stage 3 is connecting AI models. Once the MCP layer is ready and tested, we connect it with selected AI models Claude, GPT-4, Gemini, or a locally deployed model. Because the integration logic sits in MCP, switching models later does not require rebuilding system connections. In parallel, we prepare the team to work with the new AI layer. They learn how to formulate effective queries, interpret responses, and recognize when verification or escalation is needed. Training is based on the organization's real data and processes, so users begin with scenarios they already understand. After this stage, selected users can use AI as a unified access point to data distributed across systems, receiving consistent, up-to-date answers based on the integration built in previous steps. Stage 4 is scaling and development. After launching the first integrations, the organization can gradually expand AI use, adding new data sources, new models, or more advanced agent scenarios. The team receives full technical documentation and can continue development independently or with our support. Ongoing maintenance and development include monitoring the performance of MCP servers and detecting potential regressions, adding new integrations and permissions in a controlled, iterative way, and periodic architecture and security reviews based on the Polaris framework. MCP is an investment in flexibility, infrastructure that lets you change models, tools, and approaches without losing control over data and processes. It's a foundation that builds competitive advantage, not through one project, but through continuous adaptation. Model Context Protocol makes it possible to connect a distributed system landscape and consciously design how AI interacts with your organization's data and processes. The protocol won't replace strategy or organize your data for you. What it does give you is structure, so you can make decisions quickly and flexibly, regardless of which models you choose today or a year from now. You can test solutions more often, learn faster, and scale what delivers results. Want to explore what AI can support your processes today? Each month, we offer 2 free Polaris audits. Within 2 weeks, you'll receive a report assessing your data potential and a priority roadmap, with no obligations. So, check out the link in the description of the episode and book a free Polaris audit now. That's it for today's episode of TechNauts. Thanks for listening, and if this was useful, follow the podcast so you don't miss what's coming next. See you around.